Welcome back to Math. This is section 16, Factoring and FOIL. We'll do a little bit of review first, then talk about the greatest common factor, then distributing with FOIL, the first, the outer, the inner, the last, and then talk about factoring with FOIL when the x squared coefficient is 1 and when it's not 1, and the difference between squares. Just a note with this section, if this is truly new subject material for you, take it slow, pause, and be sure you understand it before you move along. First, let's review the topics of factors and like terms. Factors are the smaller numbers that multiply together to get our larger numbers. So you remember this. 12 has the factors 1 and 12. Those multiply together to get 12. 2 and 6 also can be multiplied together, and 3 and 4. You can kind of do this with trial and error, or just being very familiar with your multiplication tables will get this for you. We add on here that there's an x squared and a y, so this also has a factor of x and a factor of y. And terms are the pieces of the expressions that are separated by addition and subtraction. Like terms have the same variables with the same exponents. So for example, 4x squared plus 9x squared. Those have the same variables, x, and the same exponents, 2. So we can combine that 9x squareds and 4x squareds and 9x squareds gives us 13x squareds. But if this same problem was 4x plus 9x squared, it's got the same variables, but not in the same exponents. So these are not like terms, and they cannot be combined. So let's do some examples of combining like terms. And we have some rather long expressions here. You can do this in a variety of ways. I personally like to start from left to right, and as I go along, I underline so that I know that I've taken care of that term. And it also helps me see, this is 5. Its like term will not have any variables, so I can look all the way through here and not see another one until I get to here, 3. So 5 plus 3 is 8. Now let's take this, and I'll underline it twice so that it'll stand out for me. This is just x. I don't see any other term, though, that just has x. So I'm just going to copy that down, plus 2x. It's plus because of this plus sign. Now we've got, maybe I'll do a wavy line for y's all by themselves. I don't see any other y's all by themselves either, so minus 3y. But here, I've got a couple of x squared terms. Remember, when there's no coefficient or no number directly listed there, it means that that is 1x. So 1x squared minus 3x squareds, that would give me negative 2x squareds. And then the last one here is plus 4xy. That's totally different because it has an x and y together. So this would be our right answer. Usually, just for convention and to make things a little bit easier to read, we generally start with the highest exponents first and go downwards and list things. So we would probably start with the negative 2x squared here, and then I might take care of the plus 2x. Now we can start with the y terms, plus 4xy minus 3y plus 8. So that's a more standardized version of this. All right, let's do this one. I have an x squared term first, and I do see another one. So minus 2x squared minus another x squared, that's going to give me minus 3x squared. Let's do the x terms. Oh, there's 3 of them. So 3 plus 4 is 7, plus another 7 is plus 14x. and then this is left plus 5. And that's in a pretty standard format already. And finally this one, we have just one x squared term. I've got 2y to the 4th terms, so plus 4 of them minus 2 of them, that's plus 2y to the 4th. These aren't common terms, so plus y cubed plus 7x. Now let's review the distributive property again. This works with multiplication and with division. And remember, with multiplication it says that when you have a number, or in this case a variable, and you're multiplying it by two terms, usually in parentheses like this, you have to multiply the number by both terms. So a gets multiplied by b, that's ab, and a also gets multiplied by c. It's still plus because we keep the plus sign from the middle there. It works with division too. If we have a term, b and c, being divided by a, we can kind of split it out, that this equals b plus a, or excuse me, b divided by a, and c divided by a. In fact, when the distributive property gets a little more complicated, it means that if we have a number that's being multiplied by 3 terms inside parentheses, we just keep doing it the same way. 4 will be multiplied by this, then by this, then by this. It works for 3 terms inside or any number of terms inside. You just need to multiply 4, the number on the outside, by each one. So this is 4 times 2x, that would be 8x, minus 4y, and then we have a plus sign. 4 times 7 is 28. Let's do one more example. We have now negative 9x being multiplied by all the terms inside these parentheses. So first, negative 9 times 2. You can do the number parts first. So negative 9 times 2, it's a negative because one's negative, one's positive, and 9 times 2 is 18. X times x, though, is x squared. All right. Now the negative 9x times positive 3y. Negative 9 times positive 3, that's going to be a negative 27. And we have an x and a y, so we keep the x and y multiplied together. And finally over here, negative times a negative, this time it's going to be positive. The number part of this is 45, 9 times 5. And don't forget the x. These examples may not look like the distributive property to you because there's subtraction between these terms. But I'm going to argue that there is a little bit of distribution going on. If we want to remove the parentheses from these so that we can combine like terms, we actually have to consider that there's a coefficient of 1 out here and a coefficient of negative 1 out here, because of this negative sign in front of the parentheses. Well, to drop these parentheses, I need to distribute 1, positive 1, that's not actually going to make any changes. So I can actually just drop those parentheses, but technically I have multiplied 1 times 5x and 1 times 7. But now I need to remember that I'm multiplying this by negative 1 before I can drop the parentheses. So this is negative 3x and negative 2. I'm multiplying negative 1 times both terms. That's so that I can drop the parentheses. And once I have dropped the parentheses, I can see that I've got some like terms. 5x minus 3x is 2x, and plus 7 minus 2 is plus 5. Let's do one more. We have, in this case, there's 2 terms, but it wouldn't matter how many terms. We have subtraction going on between the 2 terms. We want to drop the parentheses so that we can combine the terms. We have to remember that there's a 1 here and a negative 1 there. So this isn't going to make any changes. When you multiply things by positive 1, it's not going to change anything. But when we multiply by negative 1, we're going to get negative 2x plus 7. Now we can combine the terms. 3x's minus 2x's is just 1x, plus 4 plus 7 is plus 11. So there is a little bit of a shortcut if you want to consider it this way. When you have a subtraction of terms that are in parentheses, you are essentially just going to change the sign of each one as you drop the parentheses. Positive 2x became negative 2x, negative 7 became positive 7. Either way you want to think about it, but really the distributive property is what's going on and what makes that work. Now let's talk about greatest common factor. Consider something like this, 2x minus 8. That's fine the way it is, but it's really not considered simplified in math. Usually what we want to do to simplify things is to remove what we call the greatest common factor. Let's think about factors again. The factors of 2x are 1, 2, and x. The factors of 8, and let's not consider that it's negative for a moment, but that's 1 and 8, 2, and 4. So it's got common factors here. So we can do what we're going to call factoring out the 2, the greatest common factor. When we divide 2x by 2, we're left with x. We divide negative 8 by 2, we get negative 4. And so this is considered a more simplified version of this. Not only that, but oftentimes when you're solving an equation or solving some sort of problem, doing this is almost always a good first step. Just to prove to yourself that we didn't actually change the value of this, you could distribute it again. 2 times x is 2x. 2 times negative 4 is negative 8. Let's look at this one. I can see right away from the coefficients 3, 12, and 6 that 3 is common in all of those. And if I'm looking at the variables, that's got an x, that's got an x, and that's got an x. So I can factor out, my greatest factor is 3x. That would leave me here with x, right, plus 4y minus 2. I divided each term by 3x. 3x comes outside of what the parentheses are. Remember, this is not an equation where I can divide both sides by 3x and sort of magically make it go away. No, this is just an expression, and to divide by 3x, it needs to stay involved. It's still going on here. It's still part of the numbers, but it can be outside. So 3x times x would be 3x squared. This would give me the 12xy, and this would be negative 6x. As we'll see in a minute, perhaps I can factor this now, but having the 3x removed from those parentheses might help make things inside the parentheses be a little bit simpler. Now let's talk about distributing with FOIL. FOIL stands for the first, outer, inner, and last. We saw just a moment ago that when we have one product outside being multiplied by several terms inside parentheses, that we had to multiply that outside number by every term in the parentheses. Well, what happens when there's two terms being multiplied by two terms? Every single term here needs to be multiplied by every single term here. And FOIL is just a way to remember an order to do that in so we don't miss something. That's all it is. We talk about the firsts, we mean the x's, the x here and the x there. They're the first things listed within their parentheses. When we talk about the outer, we mean x and negative 2. They're kind of the outside of these two parentheses. The inner would be then the opposite. That would be the 1 and the x. And then the lasts would be the last ones listed. Let's just do it and see what happens. X times x, those are the two firsts. So when I multiply x times x, I'm going to get x squared. My outers, I'm going to multiply x times negative 2, and I will of course get negative 2x. Then we'll do the inners, 1 times x, I would get a positive x. And then I'm going to multiply 1 times negative 2. I'd get a negative 2. Now there's some terms that we can combine because we've got two x terms. So the x squared minus 2x plus another x, that's just minus x, or minus 1x. I'm not going to write the 1 because it's understood. And then the minus 2. All right, let's do that one more time. The firsts, that's 2x and x. 2x times x is 2x squared. The outer, 2x times negative 2 is negative 4x. Now the inners, negative 3 times x, negative 3x. And now the lasts, negative times negative is going to give me a positive, and 3 times 2 is 6. Again, this results in common x terms that can be like terms that can be combined. Minus 4 minus 3 is negative 7, and bring down the plus 6. So that's all it is. FOIL is just a way to remember to be sure that you've got every term in the first part being multiplied by every term in the second part. Now let's talk about factoring using that FOIL. And we're going to start where the x squared coefficient equals 1. Like this. There's an understood 1 next to that coefficient. So think of distributing and factoring as sort of opposites, like multiplying and division are opposites. If you can combine things with distribution, you can uncombine them with factoring. Now we just did this problem a moment ago, and we said that the two terms that we multiplied together to get that were x plus 1 and x minus 2. So if our goal is to factor this so that we wind up with two binomials, in fact, let me explain the terms binomials for a moment. X plus 2 has two terms. That means we call it a bi, or two nomials. This has three terms, so we call it a trinomial. Tri being 3, like tricycle. So our goal is to take this trinomial and factor it into two binomials. We already know the result, but how do we get it if we don't know the result? Well, when this factor is 1, the first thing I can do is make my parentheses. And I know that the result of multiplying the firsts together, the coefficient is 1. In fact, I know that it's going to be x, because that's the only thing x times x will give me x squared. Piece of cake so far, right? All right, the result of the lasts has to be negative 2. Right? There's the result of the last. The result and the inner and the outer together, those are the terms that are going to combine, to add together. Let's start with the result of the last. We know it's going to be negative 2. Well, the terms of 2 are 1 and 2, and that's really it. They have to be negative, though. This result has to be negative. So 1 has to be negative, 1 has to be positive in order to have a negative times a positive to equal a negative. So we can either start with 1 and negative 2, or we could have negative 1 and 2. Now, those are the only two things that will work here. This is either x plus 1 and x minus 2, or x minus 1 and x plus 2 at this point. But we know that when they add together, they give us negative 1. So now we can choose the one which adds together to give us negative 1. 1 plus negative 2 gives us negative 1. And negative 1 plus 2 would give us a positive 1. So it's this one right here, plus 1 minus 2. See? It does match. Prove it to yourself that it works. X times x would give me x squared. Outer, x times negative 2 would be minus 2x. Inner 1 times x is plus x. 1 times negative 2, the last's negative 2. Combine my like terms, and there I am. Let's do another example. So again, I have this trinomial, something with 3 terms, and I'm going to try to factor it into 2 binomials. I start with the parentheses. The coefficient is still 1, so I still know that this is going to be x and x. Now, the result of multiplying the lasts together is going to give me negative 8. So let me write down the terms of, or the factors of negative 8. Negative 8 is 1 times 8, or it's 2 times 4. 1 has to be negative, 1 has to be positive in order to multiply together and result in a negative. So it could be negative 1 and 8, or it could be 1 and negative 8. And same way here, it could be this could be negative, or this could be negative. So one of these 4 combinations is the answer. But remember, they have to add together to give me a positive 2. Well, negative 1 plus 8 gives me 7. 1 plus negative 8 gives me negative 7. So it's not these. Negative 2 plus 4 is 2. Aha! I think I've got it. But let's just check this last one. 2 plus negative 4 is negative 2. So, negative 2 and positive 4 from here is going to be the answer. But always double check. First, x times x is x squared. Outer, x times positive 4 is plus 4x. Inner, x times negative 2 minus 2x. And negative 2 times positive 4, negative 8. Combine my like terms, and 4 minus 2 is 2. And I'm back to where I started from. How about one more example? Again, trinomial, x squared minus 10x plus 24. This coefficient is 1, and I'm going to try to break that down into 2 binomials. I always start with the parentheses, and I can start by filling in the result of the first, because x times x is going to be x squared. All right, let's look at the last. The result is going to be a positive 24. 24, the factors of it are 1 and 24, 2 and 12, 3 and 8, or 4 and 6. That's a lot to consider, but we can make some educated decisions about this. Now, this is positive, so they are either both positive or they're both negative. But they have to add together to give me negative 10. Well, that leaves this out and this out. 2 plus 12, that's 14. Negative 2 plus negative 12, negative 14. No, that's not it either. 3 plus 8, no, that's 11. No. Wait a minute. 4 plus 6, that's 10. And negative 4 minus 6, that's negative 10. Negative 10 is what I'm looking for. So, negative 4, negative 6. Let's prove that works. X times x is x squared. Outer, x times negative 6, negative 6x. Inner, negative 4x plus 24. Combining my like terms. And it works. Well, what happens when the x squared coefficient isn't 1? Like in this example where it's 3x squared minus 13x minus 10. This coefficient, 3, means that we have to do a little bit extra factoring. I'm still going to start with my parentheses, but now the factors of 3 are 1 and 3. So one of these has to be 3x, and one of them has to be x, in order for the result of the first being multiplied together to give me 3x squared. Okay, I still need to consider my factors of negative 10 in order to get my last. But now, which one is going to go with the 3x and which one is going to go with the 10? You can jump in and start doing some trial and error. That's perfectly fine. Or sometimes I like to make a little chart like this. And we'll start with a 3 and a 1 here. And I'll list the factors of negative 10. So I could have 1 and negative 10, or negative 1 positive 10, or I could have 2 negative 5, negative 2, and 5. Now I'm going to make another chart with the same factors of negative 10. And this time I'm going to reverse this 1 and 3 instead of 3 and 1. So what this is telling me is that the number in this column needs to be multiplied by 3 before they're added together. Now, it looks like there's a lot to check here, and you're kind of right, there is, but I can eliminate some of these just based on common sense. Like 3 times 10 is going to give me 30. That's way out of range. I just don't think that's going to be right, so I'm not even going to check these. I'm not too sure about the 10 either, but we'll try it. So this would be 3 times 1 plus negative 10. That would give me 3 minus 10, that would be negative 7. Now here's another little tip. This is going to give me positive 7, right? Negative 3 plus 10. So these are actually in pairs. So if one doesn't give you 13, the other one's not going to give you negative 13, right? So 3 times 2, that would be 6 minus 5. That would give me 1. So that's going to give me negative 1. Doesn't work. I'm looking for negative 13. All right. How about 1 times 2? That's 2 minus 15. 2 minus 15 is negative 13. Aha, I told you. So it's this one right here. But now you say, does the 2 go with the, which one does it go into? So the 2 goes with the 3, that's positive 2, negative 5. Let's just prove it works. 3x times x is 3x squared. Outsides, it was going to be negative 15x plus 2x minus 10. Combine my like terms. We'll do one more example. This one has a 6x squared. So now, there's 2 options we're going to need to consider. This is either 6x and x multiplied together, that would give us 6x squared. Or one of these might be 2x and one might be 3x. That would also multiply together to get us 6x squared. Now for my factors of 20. I could have either negative 1 and 20, or 1 and negative 20, negative 2, 10, 2, negative 10, or negative 4, 5, 4, negative 5. And again, this could go with 6 and 1, or it could be 1 and 6. Same thing here, this could be 2 and 3, or 3 and 2. Now, I'm not going to do the whole thing here in front of the video for you to watch me go all the way through this. But remember, eliminate some of the obvious stuff. We're looking for negative 7. So these really big numbers probably just aren't going to make sense. Focus your attention on the smaller numbers if you're trying to get to something like negative 7. In fact, after the trial and error, you will find that it's 3x, the plus 4 goes with this, and the negative 5 goes with that. Let's just prove that works. 2x times 3x is 6x squared. Outer is 2x times 4, that's plus 8x. minus 15x, that's my inners, and my lasts are going to be minus 20. Again, 6x squared, combining my like terms, minus 7x minus 20. Don't give up. The more practice you do, these will be more intuitive and you'll get there. And I also promise this. This is probably something that's the most complicated you'll see in an intermediate math class. Let's talk about one more part of factoring with FOIL that looks a little bit different, and that's when a binomial can be factored into two binomials. They're a special kind of binomial, though, and that's where it's called the difference between squares. When the first term is a perfect square, like x squared, and the second term is a perfect square, like 4, and it's a minus, it's a difference between these two squares. What actually happens is that you get, that's your standard beginning, but you'll have the factors of 2, or really the squares of 2, plus 2 and minus 2. And what happens is x times x is, of course, x squared. Do the outer x times negative 2 minus 2x, inners plus 2x, and then minus 4. When you combine these like terms, they actually cancel out, and you're left with x squared minus 4. Here again, here's the difference. So there's subtraction always between the two, never addition, and they're perfect squares. So 9, the square root of 9 is 3x, and then 16's square root is 4. So plus 4 minus 4, and see what happens. So 3x times 3x is the 9x squared. Outer, we'll get negative 12x and plus 12x minus 16. And again, these cancel out, and you're left with 9x squared minus 16.